This is Anthony Carruthers, Better Lesson Master Teacher Project. And in this screencast, I'll be talking about a demonstration I do for students to prepare them to do the constructions of regular polygons inscribed in circles. So the basic idea here is just to get the concepts out. This won't give away how to do the constructions, but it will give them some important concepts. So this first construction is an equilateral triangle. And for that, I'm going to start with just an arbitrary point on the circle. And I'm going to do this actually using transformations. So I would tell students that I need to find a way to rotate a point about the center of this circle so that it basically makes 3 stops, the third stop getting it back to its original position, and all 3 of those stops being equally spaced on the circle. So we would kind of reason through and maybe do some pair shares to talk about how many degrees of rotation I'll need for each point. So to get started, I'll make the center of the circle my center of rotation, and then I'm going to select this point, and then we're going to rotate. And as I said, after some discussion, we'd arrive at the fact that each rotation would have to be 120 degrees. So 120 degree rotation gets me to this point. And then that point in turn would have to also be rotated 120 degrees, so we're going to do that too. And the final rotation of 120 degrees will get us back to the original point. So from there, I can just create segments that connect those 2 points, 3 points, and I'll have my equilateral triangle. All right, so the important thing there just being that we needed 120 degrees of rotation between each successive pair of points. Okay, next we'll be creating the square inscribed in a circle. So I'll start again with the circle. Give this some labeling just so we know what we're doing. And my approach to that is going to be similar to the last construction that we did. So I can take this point and again rotate it around the center. So let's select the center as the center of rotation. And the same thing being the case here, I want to ask students how many degrees of rotation do we need so that we make 4 stops, and the 4th stop gets us back to our original position, all 4 stops being equally spaced around the circle. So we'll get that that's 90 degrees. Okay, so I want to repeat that rotation and so forth. And if I connect those points, then I will get a square. So the thing that I'm going to point out for students with the square construction is that the diameter, or rather the diagonal of the square, is a diameter of the circle. So we can notice here that if I draw that diagonal, that is a diameter of the circle. Likewise for this diagonal, also a diameter of the circle. And we would do some pair sharing, for example, to talk about the fact that a square is a rhombus. Therefore, not only are the diagonals bisecting each other, but the diagonals are also perpendicular to each other. So I will bring out that fact also as a concept. Okay, so this information will come in useful as students are using compass and straight edge to construct their inscribed squares. Okay, moving on to the case of the hexagon. Okay, again, we'll start with a circle. And by now, students should have kind of done some reasoning about the regularity that we've seen in the previous two cases. So I'd expect it to happen more quickly, that students would tell me how many degrees of rotation we'll need this time, that being 360 divided by 6. So let's rotate that point, and that's going to be 60 degrees. And we want to repeat that rotation until we have our hexagon. Okay, so that will give us our hexagon, and what I'll want to do is spend a little bit more time talking about the features of hexagons. Namely, the fact that if I were to draw this triangle here, and since we know that the measure of the angle that we rotated, this angle here, the measure of the angle that we rotated in order to create this hexagon was 60 degrees. And because this is an isosceles triangle with all radii being congruent on a circle, I know that this is also an equilateral triangle. So that's one of the main features of the regular hexagon that we want to point out. So I would just kind of diagram that by showing that this angle, and this angle are all congruent, which means also this side, and this side are also congruent. So this fact will actually be the reason why the regular hexagon would be the easiest construction to do first, and it also will give students a strategy once they realize it for constructing the equilateral triangle. So these are just some pointers that I try to give students before they're asked to go ahead and problem solve and figure out the constructions on their own. So once again, Anthony Carruthers, Better Lesson, Master Teacher Project.